Before we get started, are there any questions over the homework so far? All right. So the first one we're looking at is this one here. 4x over x squared minus 9 is equal to x minus 1 over x squared minus 6x plus 9 plus 2 over x plus 3. Now, before we get started or start trying to find the restrictions or figure out what we're multiplying through, we do need to make sure all three denominators are factored as far as possible. That way we don't have any additional factors or unnecessary factors we do not need. Now, out of the two denominators, x squared minus 9 is going to be kind of nice to factor because we have two terms being subtracted. X squared is a perfect square, it's x and x, and 9 would be 3 and 3. Telling us it factors x plus 3 times x minus 3. Now our middle term, x squared minus 6x plus 9, there is no greatest common factor. The big indicator is that x squared doesn't have a number in front of it other than 1. 9 does not have a variable. So there's nothing we can take out of all three. Now since the third term is positive, the signs are the same and match the sign of the middle term, which would be negative and negative. Only factors of x squared are x and x. Factors of the third term, factors of 9 are 1 and 9 or 3 and 3. Which one would we like it to be? 3 and 3. 3 and 3 are the correct factors, so we do get this here. Now, part of the reason I say that these are the factors we want to have is if we think about what we have to multiply through. X minus 3 showing up is already in common on all three. We do have it in other spots. It's nothing new. Where if this had been 1 and 9, I'm now having to multiply by x plus 3, x minus 3, x minus 1, and x minus 9. I'm having to multiply by 4 different expressions. That's more things to multiply, more factors we have to work with. But with it being 3 and 3, we actually have some common factors, some common things. We're not going to have to multiply as much all the way through. Our restrictions. Now, even though we do have 5 expressions in the denominator, 2 in 2 of the fractions and 1 in the third, the only real different expressions that we have showing up is x plus 3 and x minus 3. So we only have to solve for them once. With the x minus 3, we would add 3 to both sides, telling us if x is equal to 3. Thank you. We have a denominator of 0. For x plus 3, we would minus 3 from both sides, telling us that if x is equal to negative 3, we have a division of 0. That does not work. So our two main restrictions for this here is 3 and negative 3. If one of those two shows up, we throw it out. Questions on this here before we start figuring out what to multiply by? What's one of our expressions we can multiply through by? X plus 3. And if we're not sure what we need or how many of them that we need it, start one at a time. Just start one at a time and see what we have left over. So if I start with x plus 3, on the far left, the x plus 3 and x plus 3 would cancel. In the middle expression, the x plus 3 on top is not going to simplify with either one on bottom because the two on bottom are x minus 3. And on the far right, the x plus 3 and x plus 3 would. Well, we still have denominators, so we'll multiply by x minus 3. And on the far left side, that fraction, the x minus 3 on top that we're multiplying it by, would cancel with the 1 on bottom. On the far right, that x minus 3 won't simplify with anything because there's nothing left on bottom. And the middle one, the x minus 3 on top, would simplify with what? X minus 3. What about the other one? We only did it once. We only have 1 on top, so it only simplifies with 1 on bottom. Are all the denominators gone? No. We've got to multiply by another x minus 3. And at this place, the only one that's left is the one in the middle. So this is one of the nice things about taking it one expression at a time, because here we're able to get them all, we can find them all. Where if we didn't need that second expression of x minus 3, doing it once would have showed us we didn't need it a second time. Questions on this here? So let's see what's left. In the first, on the far left, we have the 4x. X plus 3, x minus 3 simplified. But the second x minus 3 did not. So we have 4x and x minus 3. In the middle expression, we have the x minus 1 on the top. And the only thing that didn't simplify that we were multiplying it by was x plus 3. Plus 2 times x minus 3 times x minus 3. Questions on how we got to this point here? Now we can start multiplying out and simplifying down. On the left-hand side, we can distribute that 4x. 4x times x is 4x squared. 4x times negative 3 is going to be negative 12x. 4x and negative 12x, 4x squared, negative 12x, are they like terms? Can we combine those? No. So there's a good chance we're just going to end up writing 4x squared minus 12x several times down, because there's nothing we can do there until the right-hand side, the other side of that equation, we get simplified down. We got the like terms, so it might be a minute. Now on the right-hand side, the first thing I'm going to multiply is the x minus 1 and x plus 3. So we'll distribute the x first. X times x is x squared. X times 3 is plus 3x. Negative 1 times x is negative x. And negative 1 times 3 is negative 3. Plus 2. Now we need to multiply x minus 3 by x minus 3. We're going to wait on the 2, because we could multiply the 2 by the first x minus 3, or we can multiply it by the second one. We cannot do both, because we only have 1 2 there. So we're going to do the x minus 3 times x minus 3 first, and once we find that product and we know that it's x squared minus 6x plus 9, then we would multiply by 2. Well, where did we get x minus 3 and x minus 3 from? Weren't they the factors of x squared minus 6x plus 9? So if we see that, we could just rewrite it as x squared minus 6x plus 9. If we don't, x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3 times negative 3 is plus 9. And if we do combine our like terms in that set of parentheses, negative 3x minus 3x is indeed negative 6x. So we get to the same spot. If we notice that ahead of time, we could just replace it. We're good to go. If we didn't, we can multiply it out and get to the exact same spot. Our other set of parentheses, we can go and combine those terms. 3x minus x would give us plus 2x. Now we need to finish solving those parentheses. Luckily, the x squared plus 2x minus 3 is just that. Since there's nothing in front of it, there's no number in front of the parentheses, there's no sign, no negative, we can just drop the parentheses, we're good. The other set of parentheses, we've got to distribute that too. 2 times x squared is 2x squared. 2 times negative 6 is negative 12x. And 2 times 9 is plus 18. I think we have a few like terms on the right-hand side. Now, really, we haven't explicitly talked about this. I mean, it's been a while since we talked about combining like terms. I always start with the variable with the biggest exponent. Just put it in standard form. So our x squared plus 2x squared is 3x squared. Then we go to our x terms. 2x minus 12x. Negative 10x. And lastly, our constant terms, negative 3 plus 18 would be plus 15. Questions on how we got here? We finally got both sides simplified down. Now we can start moving things from one side to the other. Normally, I would try to keep the x squared term if positive, if at all possible. The only reason I wouldn't, if it's going to take more terms, it's going to take me more steps to move all the terms to that side than it would be to just move them the other direction. Because at this point here, we could move the 3x squared over, we can move the negative 10 over, and then move the negative 15 over. Or I can move those two over and get to the same spot, or an equivalent spot. And I'd rather just move the 2 instead of moving the 3. So we can add 12x to both sides. Negative 12x plus 12x would simplify. Telling us that we have 4x squared is equal to 3x squared plus 2x plus 15. Then we would 3x squared minus 4x squared would be negative x squared plus 2x plus 15. Now, the fact that that first term is negative isn't a real big issue or a problem with this here. We just have to figure out and simplify it out so that we get it into a nice form. But questions on this here before we start factoring? Now, our terms that we have, x squared, 2x, and 15, there's no common factor between them. But one thing I'm going to want to do, especially if I'm factoring this, is to factor a negative 1 out of all three terms. Because if I factor negative 1 out, the number-wise, I'm still going to have x squared, I'm still going to have 2x, I'm still going to have 15. Because dividing everything by 1 doesn't change anything. But since we divided it by negative 1, that negative x squared is going to become positive. That positive 2x is going to become negative. And that positive 15 is going to become negative. So really all we did was go through and flip all the signs so that our a term's positive, It's going to make it easier to factor. Questions on this here? All right. So, not the one I wanted ended, but that's fine. So, since we have the a term positive, we can go on and factor this here. Since the third term is negative, our signs are opposite. One's going to be plus, one is going to be minus. Our only factors of x squared are x and x. And our factors of 15, our numbers that multiply together to give us 15. 1 and 15, 3 and 5. Where are we going? 3 and 5. Which one do you want positive? Which one negative? Positive 3, negative 5. And we check and make sure x times negative 5 is negative 5x. 3 times x is positive 3x. Negative 5x plus 3x would be negative 2x, and that is indeed the middle term that we wanted. So we have the correct factors. We have 2 or more things that multiply together that equal 0. So either x plus 3 is 0 or x minus 5 is 0. Solve for x. So with x plus 3, we would subtract 3 from both sides, telling us if x is equal to negative 3, that's one of our solutions. And with x minus 5, we would add 5 to both sides, telling us x is equal to 5. Do we have a restriction? Which one? X equals negative 3. Since it is one of our restrictions, we just mark it out because it is an extraneous solution. It is a solution that we get from solving, but it just does not work in the original context. Bless you. Questions on this here? We ready for the next one? Do what? Yeah, I do want it. And especially on the test, I do want it because it does have 2 solutions. One of them just does not work in the original problem. We still have 2 values of x that work. One of them is just an extraneous solution. We have to get rid of it. Here in a bit. Quickly. So, the only denominator that we have here that is not factored, that we need to factor, is x squared minus 4. 2 terms being subtracted. X is a perfect square. It's x and 4 would be 2 and 2. So it factors 2. X plus 2 times x minus 2, or x minus 2 times x plus 2. So that was the only thing we really needed to factor. Now our restrictions. Yes, on both accounts. So x plus 2, we would subtract 2, saying x If it's equal to negative 2, we'd have a division of 0. Doesn't work. With our x minus 2, we'd add 2. Telling if this x is equal to positive 2, we'd have a division of 0. It doesn't work. And we could actually combine those two statements and just say x cannot equal plus or minus 2, positive or negative 2. Now, what do we need to multiply everything by? Well, we can start off with x minus 2. Because 2 of the 3 rational expressions in this equation, the x minus 2 would cancel on top and bottom. But we're also going to need the x plus 2. Now on the left-hand side, we still have the 9 times x plus 2 plus 6x times x minus 2. Because we still had one term besides the numerator left over, equals. Well, the only thing left on the right-hand side is 9x squared. Which means most likely, no matter what happens, I'm probably going to move that 9x squared over to the left-hand side than trying to move whatever we have on the right, left to the right. I'm going to distribute the 9 first, so 9 times x is 9x, 9 times 2 is plus 18. 6x times x is 6x squared. And 6x times negative 2 would be negative 12x. Combine like terms. 6x squared does not have any like terms, so it's going to be 6x squared. 9x minus 12x would be negative 3x. 18 does not have any like terms, so it's just plus 18. Questions on this here? Now, if we wanted to, we could keep that x squared term positive. I'd subtract 6x squared from both sides, but then we'd have to add 3x and subtract 18. We'd have to move 3 things from the left side to the right side, which is not wrong. You can do it. It works. I would rather move 1 thing, not 3 things. Because if we subtract 9x squared minus 9x squared is indeed 0. 6x squared minus 9x squared, 6 minus 9 would be negative 3x squared minus 3x plus 18. Is there a greatest common factor amongst these 3 terms? Three. Specifically, we're going to want to factor that negative 3 out. And the reason I say I want to factor a negative 3 is I want to get that first term to be positive. It's going to be nicer, easier to factor with positive x squared terms than it would be with negative. Just for whenever he gets back. Now, if we factor the negative 3 out of negative 3x squared, factoring the negative is going to make it positive, and the 3 factors out completely. Our second term, I factor that negative 3 out of negative 3x. It's going to make it positive. 3 factors out completely. We're just left with x. Now, the positive 18 is going to become negative because we're factoring a negative out. 18 divided by 3 is So just factoring the 3 out is going to make it a little bit nicer to work with, and factoring the negative out makes it even more so. Questions on this so far? Since the third term is negative, our signs are opposite. One's going to be positive, one is going to be negative. Factors of x squared, x and x. Our factors of 6 are 1 and 6, or 2 and 3. Which one do we want to try first? 2 and 3. And we can make sure this is set up right. X times negative 2 is negative 2x. 3 times x is positive 3x. Negative 2x plus 3x, negative 2 plus 3 would give us positive 1, which is the middle term we wanted. Questions on how we got here? Two things multiplied together to equal 0, so one of these has to be 0. Either x plus 3 is equal to 0, or x minus 2. Well, our x plus 3 we would subtract 3, telling us x is equal to negative 3. X minus 2 we would add 2. So the two solutions we get is x is equal to 2 and x is equal to negative 3. Is either one of these a restriction? Which one? 2. X cannot equal 2 because it is a restriction. Questions on this here? Interestingly enough, if it's not the case here, we said that negative 3 was also a restriction, would we have any left? No, if I remove all my solutions because they're restrictions, that tells me it is no solution because there is no value of x that can make both sides be the same. And incidentally, the only solution that we could possibly get both sides to be the same, specifically the numerators, is a value of x that would make the denominator be 0, so it doesn't work anyways. Questions on this here? One more time? If all those solutions are thrown out. All right. I went on and factored the denominators for us. So x cannot be 1, negative 1, or 2. So I'm going to give you the restrictions. We're going to give you this setup so far. Now we need to see what we're going to multiply everything by. What's one of our expressions? Now the expression we start multiplying everything by really doesn't matter. We just need to make sure we get them all. So I can start with x minus 1. Well, the fraction on the far left, the x minus 1 and x minus 1 would cancel. And that's actually it. Then we can move on to x plus 1. Our middle expression, the x plus 1 and x plus 1 will simplify. In the far right, the x plus 1 and x plus 1 will simplify. Do we have anything left in the denominator? Yeah, we got an x minus 2. So that means we also have to multiply everything by x minus 2. Well, our far right, the farthest right rational expression is the only thing that had something left. So it simplifies so that x minus 2 stays with the first two. So what that leaves us with is 2 times x plus 1 times x minus 2 for that far left rational expression, plus 1 times x minus 1 times x minus 2. There's not a whole lot of reason to write the 1 times that because it's understood to be there. Equals, what's left in that last one? Well, the only term that didn't simplify on the right-hand side was x minus 1. Now we need to do some simplifying. Now we do have this 2 being multiplied with these two sets of parentheses. And again, it might be very tempting to multiply the 2 with the x plus 1 and the x minus 2. But we only have one factor of 2. We only have one 2 there. We can't multiply it through both. So to make sure we don't multiply the 2 by these two sets of parentheses too many times, let's do the parentheses first. X times x is going to be x squared. X times negative 2 is negative 2x. 1 times x is going to be plus x. And 1 times negative 2 is negative 2. Plus. Now we're going to do our next two sets of parentheses here. X times x is x squared. X times negative 2 is negative 2x. Negative 1 times x is negative x. And negative 1 times negative 2 is plus 2. Yep. Questions on how we simplified the left-hand side so far? Is there anything else besides that x minus 1 on the right-hand side? Do I need the parentheses around it then? So really that right-hand side is just x minus 1. Inside both these sets of parentheses, we do have like terms. So the first one, negative 2x plus x, is negative x. So in the first set of parentheses, we have x squared minus x minus 2. Plus, in the second set of parentheses, our negative 2x minus x would be negative 3x. Do I really need those parentheses on that second one? No. But I do need them on the first one because we still have that product of 2 that will need to be distributed through. 2 times x squared is 2x squared. 2 times negative x is negative 2x. 2 times negative 2 is negative 4. Questions on this here? Now we could start getting this equation equal to 0 as long as we've got kind of all of our terms combined. But on this left-hand side, we do have a few like terms. Our 2x and x squared, 2x plus x squared. Sorry, 2x squared plus x squared would be 3x squared. We got 3 of them. Negative 2x minus 3x would be negative 5x. And lastly, negative 4 plus 2 is negative 2. Now we do have all of our like terms combined on the left side and the right side individually. So what do we want to subtract first? Well, we can subtract x. Because our x minus x would be 0. Now we would have 3x squared. Negative 5x minus x, negative 5 minus 1 would be negative 6. So we have 3x squared minus 6x minus 2. Then what would we do? We can add 1 on both sides, because our negative 1 plus 1 would indeed be 0, telling me that I have 3x squared minus 6x minus 1. Questions on how we got here? Now, when we factor something, we're trying to really find the factors of the first and third term that get us to the middle. Yes? And here, we're saying that the factors of 3 and the factors of 1 will somehow get us to 6. That's probably not likely. Now, the signs are going to be opposite, so the best case scenario is that we get to, let's see here, 2. So there's a good chance this does not factor. Which is perfectly fine. It just means we have to use the quadratic formula to get there, to get to the actual result, the answer. And as daunting as the quadratic equation looks, especially the first time we hit it, really we're just plugging in values and simplifying as far as possible. Now looking at this here, our value of A for us is what? 3. B? Almost. It's going to be negative 6. We take the negative with it. And C would be negative 1. Now we just need to go through this formula and replace A, B, and C with their corresponding values. So the first thing we have is negative B, which in our case would be negative 6. Plus or minus a square root, so B squared would be negative 6 squared. Minus 4 times A times C, well 4 times A, so it'd be 4 times 3 times negative 1, all over 2 times 3, 2 times A. Now the first thing I would simplify is our negative, because the negative 6 is going to become positive 6. So on bottom, 2 times 3 is 6. Bless you. Now, depending on how that radical reduces or simplifies, there's a good chance we're going to have a common factor of something because of our 6 and 6. Now, at this point here, I'd grab the calculator and type everything that's inside that radical. So that negative 6 squared minus 4 times 3 times negative 1. Do make sure to put that negative 6 in parentheses, because without it, it's going to change the value of this significantly. Because it should be 48. Now we do want to take the square root of it just to make sure it doesn't reduce. And it does tell us that it does reduce to 4 square roots of 3. telling us that x is equal to 6 plus or minus 4 square roots of 3 all over 6. Yeah, so we let the calculator do the simplifying the 4 square roots of 3. Or square root of 48 to 4 square roots of 3. Now we can say this is the final answer. As long as the two numbers on top, we don't care about what's inside the radical. The two numbers on top, in our case 6 and 4, as long as those two numbers do not have a common factor with the denominator of 6, we can say this is finished. But they do. They all have a common factor of 2. 6, 4, and 6 are all even. And we can simplify that 2. We can divide that 2 out. And if I divide the 2 out of the 6 on top, it's going to become 3. If I divide the 2 out of the 4, it's going to become 2. And when I divide that 2 out of the denominator, it's going to become 3. Telling us that our two solutions are 3 plus or minus 2 square roots of 3 all over 3. Is either one of those solutions a restriction? No, because if it was, it'd have to be 1, -1, or 2. Questions on this here? And that is it. Two of these problems, you're going to have to use the quadratic formula for. Possibly 29 and 30.